Good evening. I'm Steve May with the Federal Aviation Administration. Tonight we will provide an update on the Southern California airspace modernization, more specifically, the Southern California Metroplex. I am joined by Rob Henry, Southern California Metroplex Project Manager, and Jose Gonzalez, Southern California Metroplex NATCA Co-Lead. The airports we will be focusing on tonight will include Long Beach and Orange County John Wayne airports. The procedures that will be implemented on the March 2nd and April 27th chart publication dates will be our focus for tonight's presentation. Fundamental to meeting the overall next-gen air traffic management, there has been and still is the need to evolve air traffic to a time-based system. An aircraft must be capable of receiving dynamic and complex instructions from ground systems that identify where they need to be and at what time. This requires the FAA to implement digital communications, leverage advanced navigation performance and flight management systems, and design and implement new airspace procedures. Once NextGen is fully implemented, we will be able to identify the location of each aircraft at any point in time along the way to its destination. This will have a tremendous impact on our ability to manage air traffic more safely and efficiently. Looking at the Southern California Metroplex study area, the study area covers a large portion of Southern California from Santa Barbara to Palm Springs and down to San Diego. It includes 6 major airports, including Bob Hope Airport, Los Angeles International Airport, Long Beach Airport, Ontario International Airport, San Diego International Airport, and John Wayne Orange County Airport. There are also 15 satellite airports within the study area. The goals of the Southern California Metroplex include improving flexibility and predictability of air traffic routes through increased use of performance-based navigation. The improvements will be achieved by utilizing satellite technology and publishing and implementing advanced procedures. Tonight we will look at several procedures, including area navigation, abbreviated as RNAV, standard terminal arrivals, abbreviated as STARS, standard instrument departures, abbreviated as SIDS, required navigation performance approach procedures, abbreviated as RNP, and optimized profile descent, abbreviated as OPD. Area navigation is a method of navigation that mitigates the limitations of an aircraft navigating from one ground-based navigational aid to a satellite system providing point-to-point operational capabilities. Standard terminal arrival route is a specific repeatable path with lateral and often vertical descent guidance for arrivals to an airport. Standard instrument departure is a specific repeatable path with lateral and often vertical climb guidance for departures from an airport. Required navigation performance, or RNP approach, is an approach providing a higher level of precision than an approach using ground-based navigation. And finally, optimized profile descent is a procedure that keeps arrival aircraft at cruise altitude as long as possible before beginning an uninterrupted descent. Once begun, the procedure departs from the usual pattern of stair-step descent all the way down to landing. We took a phased approach to executing the Southern California Metroplex project. We started out with study team phase, which completed in December 2011. This phase included potential opportunities and operational issues were identified to determine if a benefit could be developed through the application of performance-based navigation procedures and airspace changes. The designs were highly conceptual. The next phase was the design team phase and was completed in March 2014. This phase was used to refine the study team recommendations and conceptual designs into final, implementable, performance-based navigation procedures and airspace designs. The next phase was the evaluation phase, and it was completed in August of 2016. Within this phase, the proposed procedures were evaluated to determine if they met operational, environmental, and safety requirements. And the final phase is the implementation phase, which began on August 31st, 2016, and is currently ongoing. After issuance of a finding of no significant impact record of decision, activities in this phase are to complete and execute the implementation of the procedures developed during the previous phases.
Good evening, I'm Rob Henry, SoCal Metroplex Manager. Let's begin our procedure discussion with departure and landing direction or runway in use. Wind direction and velocity are key factors used to determine departure and landing direction. Wind speed below 5 knots is negligible. Runways are typically identified by their runway magnetic direction. For example, the west flow runway at San Diego International Airport, or SAN, is 275 degrees magnetic. The last digit is dropped and it becomes San Diego runway 27. The rationale for operating into a headwind is simple. More wind flying over the wings provides more lift at lower ground speeds. A tailwind makes an aircraft faster across the ground, requiring more runway length. Southern California airports typically experience westerly winds which favor west operations. Two terms you're going to hear a lot when we talk about satellite-based routes are optimized profile descents and optimized climb profile. Here's how they work. First, the optimized profile descent. Please note the dotted blue line. This represents current flight operations. A traditional descent is like walking down a flight of stairs. Based on air traffic control instructions, the pilot descends and applies speed brakes, then levels off and powers the engines up, then descends and applies the speed brakes again. The cycle repeats itself until the plane is on its final approach to an airport. Please notice the solid blue line. This represents an optimal profile descent. By contrast, the optimized profile descent has built-in speed and altitude restrictions at various points on the route. These restrictions are designed to provide automatic separation from aircraft on other routes by either vertical altitude separation or lateral distance separation. This information is programmed into the airplane's flight computers and allows the aircraft to glide down to an airport at near idle power. And controllers no longer have to issue instructions after clearing the plane to begin its descent. OPDs are safer in that there is less pilot-controller interaction.
Airplanes flying OPDs versus a traditional descent generate less noise and emit less pollution because their engines are at near idle and speed brake use is minimized.
Please note the yellow area on the chart. The yellow area depicts a dispersed vectoring area. Current arrival procedures utilize ground-based navigation and radar vectors. Controller vectoring creates high workload for air traffic controllers and flight crews. Vectoring creates an inconsistent flight path, creating wide dispersion for arriving traffic. Vectoring also provides inconsistent vertical profiles as controllers assign altitudes. Arrival procedures are not connected to the approach. RNAV RNPs. In this example, two arrival routes or stars are connected to the RNP. Our RNAV star connects arrival routes to the RNAV RNP procedures. Star approach connectivity provides repeatable and predictable flight paths. It simplifies operations for the flight crews and air traffic control, allows for the use of flight deck automation, and provides for a stabilized and efficient approach operation. Optimized climb profile. A traditional climb profile is like walking up a flight of stairs. Based on air traffic control instructions, the pilot climbs and then levels off and powers the engines up and then climbs again. This cycle repeats itself until the plane is at final cruise altitude. By contrast, an optimized climb profile has built-in speed and altitude requirements. At various points on the route, these restrictions are designed to provide automatic separation from aircraft on other routes. This information is programmed into the airplane's flight computers and allows them to climb at optimal power, and controllers do not have to issue instructions after clearing the plane to climb. An optimized climb profile is much more efficient than traditional climbs and is the key benefit that we are seeing today from our use of satellite-based routes. Optimized climbs are safer due to less pilot-controller interaction. Airplanes flying optimized climb profiles versus a traditional climb generate less noise and emit less pollution. The benefits that we're seeing are reduced air traffic control task complexity, reduced communications between the flight deck and air traffic control, reduced phraseology, reduced frequency congestion, reduced pilot workload, repeatable, predictable flight paths, accurate fuel planning, and laterally or vertically segregated flows.
Let's take a look at the National Environmental Policy Act. The Southern California environmental assessment process began with study team participation in November of 2011. The draft environmental assessment was released on June 10, 2015, and the public comment period was open for 120 days. The finding of no significant impact record of decision was signed on August 31, 2016. And the final environmental assessment is available on the Southern California Metroplex website. We will provide the website information to you towards the end of the briefing. The finding of no significant impact record of decision enables the agency to move forward with replacing dozens of existing conventional air traffic control procedures with new satellite-based procedures. FAA began phasing in the use of the procedures starting in November 2016 and continuing through April 2017. When the Southern California Metroplex procedures are implemented, some people might see aircraft where they did not previously fly. This is because some air route changes will occur and because satellite-based procedures create more concentrated flight paths than conventional procedures. Some people will experience noise decreases or increases, and some will experience no changes at all. Some flight track dispersion will continue to occur after the new procedures are implemented because the Metroplex project includes a number of existing procedures. Also, air traffic controllers will need to occasionally vector aircraft for safety or efficiency reasons, or to reroute them around weather systems. The following noise maps are created to enhance the understanding of all potential noise changes in the study area. Please note that many of these changes occur at noise levels at or below the noise level experienced in everyday living situations in the area. The noise maps represent noise changes of DNL plus or minus 1 decibel. For many people, the small change is difficult to distinguish. The FAA DNL metric is a value representing the aircraft's sound level over a 24-hour period and includes all of the sound energy generated within that period. The DNL metric includes a 10 decibel weighting for noise events occurring between 10 p.m. and 7 a.m., which we considered as nighttime noise events. The FAA did not use these maps for decision purposes. The noise maps are provided for disclosure purposes only. This next slide looks at increase and decrease in DNL at or above DNL 45 A-weighted decibels, or dBA. In the map, you will see a blue shaded area. This represents DNL decrease. You will also see a green shaded area, which represents DNL increase. The bold line around Southern California area is the general study area boundary, and the smaller lightly shaded polygons are the community or city boundaries. The 45 and above decibel noise level map is provided based on FAA's established criteria for changes in noise levels. This next map looks at increase and decrease in DNL at or below DNL 45 dBA. Once again, the blue denotes DNL decreases and the green denotes DNL increases. And again, you will see the general study area boundary and the communities and cities within the general study area. Although there is no established FAA criteria for changes below 45 decibels, this map displays those changes to enhance the understanding of all potential noise impacts in the study area and is provided for informational purposes only.
Community engagement. Southern California community engagement began with early notification of the environmental assessment on January 21st, 2014. The FAA conducted 11 public workshops. The workshops were conducted from June 16th through July 1st, 2015. Workshops were held in Santa Ana, Santa Monica, Los Angeles, San Diego, Palm Springs, Torrance, Long Beach, Ontario, Ventura, Santa Barbara, and Burbank. The FAA extended the public comment period for a total of 120 days, ending October 8, 2015. Approximately 4,000 individual comments were received. Approximately 2,700 unique comments and or form letters were received. Approximately 380 comments were received after the public comment period closed. However, these comments were included in the environmental assessment. Approximately 570 comments were received from 3 online community groups. Responses to comments are included in the environmental assessment. Based on community comments, the FAA reviewed all procedures. Our analysis consisted of reviewing the following. First, safety. Will the change have an adverse impact on safe operations? The team considered aviation safety information analysis and sharing data with potential impact to airspace, procedures, and enhancement of safety. We looked at traffic collision avoidance system hotspots, terrain avoidance warning system alerts, and high-energy descent and approach events. Next, we looked at efficiency. Will the change create substantial inefficiencies in operation? Next, we looked at complexity. Will the change increase workload beyond a reasonable level for controllers or flight crews? Next, we'll look at the March 2nd and April 27th, 2017 procedure and implementation. This chart shows the procedures that will be implemented for Long Beach and Orange County on March 2nd, 2017 and April 27th, 2017. Let's begin with Orange County procedures. First, let's look at the chart. In the upper left corner of the chart, you will see an inset. The inset will show darker blue lines, which represents actual flight tracks flown into both Orange County and Long Beach. Also on that slide in the inset, you'll notice the orange line. Those are the stars proceeding into the airports. Moving out to the larger slide, you'll notice again the orange lines, which indicate the standard terminal arrival routes into the airport, with arrows that denote the name and the direction of flight. Let's begin with the upper orange line and the waypoint Caden. It's indicated by a white star. This is a satellite-based navigation fix. The name is indicated as Caden. The altitude is at or below 13,000 feet. Proceeding down the star, well, again, you'll notice the name Ruby Star. And again, coming to the next waypoint, Jitsu. The yellow area depicted on the chart is the environmental assessment area. So we'll begin with the Disney 1. The Disney 1 star replaces the Orange County Long Beach Kepler star with OPD benefits for Orange County South Flow arrivals, landing runway 20 right, and Long Beach arrivals. The Disney is deconflicted from the Burbank Van Nuys Throne and the Ontario Eagles and Scooby Stars. Vertical restrictions were added to deconflict from other stars and standard instrument departures, including the Los Angeles Angel Star. Next is the Ruby 1. It replaces the Orange County and Long Beach Kepler star with OPD benefits for Orange County North Flow arrivals, landing runway 2 left, and Long Beach arrivals. Ruby 1 is deconflicted from the Burbank Van Nuys Throne and the Ontario Eagles and Scooby Stars. Altitude restrictions were added to deconflict from other stars and SIDS, including the Los Angeles Angel Star. The next slide is a closer in view of both the Disney and Ruby stars. Again, if you'll notice on the chart itself, you have the yellow area indicating the environmental assessment area or the dispersed path. The stars are indicated in orange, again, labeled with the name, and the white stars indicate satellite-based navigation. Go ahead. The next procedure we'll look at is the Los Angeles Goats 1 star, the Ontario Carl B 1, the Long Beach Bob 1 star, the Long Beach Pacific 1 star, the Orange County OC 1 RNAV star, and the Orange County Tilt 1 RNAV star. The new stars designed for Los Angeles, Long Beach, Ontario, and Orange County arrivals are from over-ocean operations. They're designed to limit interaction with other departure and arrival procedures in the Southern California area. The Goats and Carl B allow aircraft to be as much as 7,000 feet higher over Catalina Island. The Goats, Pacific, OC, and Tilt stars tie into the new RNP approaches. The Long Beach, Fullerton, Seal Beach, Torrance, Red Hill 1 RNAV star. Before we move on with the procedure, I want to note the difference in this chart from the arrivals is that SIDS are indicated in magenta. The area that's evaluated environmentally is evaluated with the magenta color, and the SID again is indicated in magenta. The Red Hill 1 serves prop departures from Long Beach, Fullerton, Seal Beach, Torrance, and to the northwest and northeast. It serves large and small non-jet aircraft operating at speed at 180 knots or less. Altitude restrictions were added to the procedure to reduce interactions with Los Angeles departures and deconflict from the Los Angeles Angel and Hollywood stars. The Long Beach, Orange County, Fullerton, Seal Beach, and Torrance departure SID Hawks 1. Currently, the Anaheim SID for Long Beach, Orange County, Fullerton is a conventional procedure relying on ground-based navigation. The Hawks 1 will replace this procedure. The Hawks serves props and turboprop aircraft for Fullerton, Long Beach, Orange County, Torrance departures to the northwest. It's deconflicted from the Los Angeles Ryder, Hull, and Ironman star. Additionally, it is separated from military airspace restricted area 2519, indicated just slightly offshore. Next, we'll look at Orange County Piggin 1 RNAV SID and the Orange County Plaza 1 Prop SID. The Piggin 1 replaces the Strel SID off of runway 20 right for eastbound departures and provides a standard instrument departure for runway 2 left where there is no current departure procedure for east or southeastbound flights. Altitude restrictions were added to the procedure to deconflict from Victor 23 Airway, the Ontario Raji SID, and the Los Angeles Sunset Star. Lateral tracks were designed in conjunction with the Los Angeles DOTS, the Long Beach Fritter, and the Santa Monica PV SIDs. The Plaza 1 RNAV SID. The Metroplex team developed the Plaza as an RNAV SID for aircraft filed to the northwest and northeast. Altitude restrictions were added to the procedure to reduce interaction from Los Angeles and Santa Monica arrivals. Again, this SID serves prop departures only. The Long Beach Fritter 1 RNAV SID and the Long Beach Zoom 1 RNAV SID. The Fritter 1 SID is designed to replace the current scenic SID. It will provide a more repeatable and predictable path for east and southeastbound departures from Long Beach, reducing complexity and increasing safety. The lateral tracks were designed in conjunction with the Los Angeles DOTS, Ontario Raji, Orange County Piggin, and the Santa Monica PV SIDs. The Zoom 1 is an RNAV departure, replacing the scenic SID and the Daggett transition. The current scenic SID only serves Long Beach runway 30, while the Zoom serves Long Beach runways 12 and 30. Altitude restrictions were added to provide to the procedure to deconflict from Los Angeles arrivals and reduce complexity. It will provide a more repeatable and predictable path. Orange County FINS 1 is designed to replace the current Muscle SID, which is a conventional procedure relying on ground-based navigation. The FINS 1 serves Orange County runway 20 right departures to the northeast, and it is deconflicted from overflight traffic on Victor 23. Orange County Hobo 1 is designed to replace the Irvine SID, which is a conventional procedure relying on ground-based navigation. It serves Orange County runway 2 left, departures to the northeast. It is also deconflicted from Los Angeles arrivals and overflight traffic on Victor 23 Airway. Orange County Hero 1 is designed to replace the current Channel SID, which is a conventional procedure relying on ground-based navigation. It serves runway 20 right departures to the north. It is deconflicted from the Los Angeles Goats, the Long Beach Bob, and the Orange County Tilt Stars. Additionally, it is deconflicted from overflight traffic on Victor 23 Airway. The Orange County Micah 1 RNAV SID serves Orange County runway 2 left, departures to the west and northwest. It provides an RNAV procedure with more predictable flight paths. Long Beach Topham 1 RNAV SID. Currently, there are no published procedures for Long Beach departures to the west and northwest. The Topham 1 serves Long Beach departures to the west, north, and northwest from runways 12, 25 right, and 30. This procedure will only be used when Los Angeles aircraft are departing to the west. It is deconflicted from the Long Beach arrivals, Los Angeles arrivals and departures, and Burbank and Van Nuys departure. Additionally, it is laterally separated from military airspace, restricted area 2519, and warning area Whiskey 289.
General project information. This briefing is for informational purposes and does not reopen the Southern California Metroplex environmental. Any noise issues should be directed to the appropriate airport noise office. Information about the Southern California Metroplex project is available on the Metroplex website. This presentation will also be available online. Additional public information. Before publishing the procedures, the agency is conducting public information meetings and webinars to further inform people about the changes. The FAA will notify the public through press releases and on Facebook, Twitter, Instagram, the Metroplex website, and possibly other additional platforms. The currently scheduled community engagement is highlighted in the following table. Note that this presentation is one of the 4 listed internet-based webinars, and that in the following weeks we will conduct a total of 10 community informational briefings. Please refer to the Southern California website for times, locations, and content for each of the community informational briefings. And now for the Southern California Metroplex website information. The first link indicates the Southern California Metroplex Environmental Assessment website. This is the main web page for the website, and all other web pages can be found by navigating to this web page. For specific information, we noted the frequently asked questions and the various environmental assessment documents and Google Earth files. Additionally, the final environmental assessment, Appendix F, contains the FAA responses to public comment. Due to the large size of this appendix, it was broken down into 3 files. Each of the 3 volumes is available on the website using the following URLs. Once again, this presentation will be made available on the website. This concludes our formal presentation, and we will now move to the questions and answer portion of tonight's webinar.
Steve, we had a couple questions come in, and I'll go ahead and get us started with that. It started with a statement and said, this is good information, but where can I get more specific information on the procedures? Great question. More information can be found on our FAA website. The FAA is also providing 10 public workshops starting next week throughout different communities in the Southern California area. FAA subject matter experts will be available to explain the procedures in depth and answer questions, and we welcome the public to our workshops.
All right, thanks, Rob. I got a couple more questions here. The first one is the FAA taking into consideration comments that I may have, and if so, how do I submit them? A public comment period was provided during the draft environmental assessment phase of the project in the summer of 2015. The FAA evaluated and responded to more than 4,000 public comments received during the 120-day public comment period, and the final EA, environmental assessment, was issued August of 2016. So these comments and all project documents can be found on the Southern California Metroplex project website at metroplexenvironmental.com. Next question I have, how can I find out more information about noise in my neighborhood? So navigating to the environmental assessment website provides detailed instructions on how to determine noise changes on Google Earth.
The next question we had is, will the FAA be monitoring the effectiveness of these new procedures? The FAA monitors deviation from expected flight paths during the implementation process, according to FAA orders. During this phase, the operation of the procedure observed to ensure they perform as expected and meet the purpose and need of our project. The next question, have these routes already been implemented? Some of the procedures were implemented in November, but all the procedures discussed this evening will be implemented in March 2nd or April 27th.
All right, thanks, Rob. A couple more here. Will there be more webinars prior to April 27th implementation? Currently, the only plans are for the webinars listed in the presentation here. Next question, are you currently increasing capacity at John Wayne Airport? The FAA does not determine capacity or flight schedules for any of the airports.
The next question is do the Disney and Ruby Stars change how aircraft arrive into Orange County? The Disney and Ruby Stars are RNAV procedures that will provide repeatable and predictable flight paths into John Wayne and Long Beach airports, thereby enhancing safety. The tracks of these new procedures remain within historical or current flight tracks. And the final question we received tonight, Steve, was, will aircraft continue to fly over Noise Monitor 7? The new procedures were designed, wherever possible, to remain within existing historical flight tracks. The FAA considered several variations to mimic the existing departure procedures from Orange County runway 20 right. The new procedures will achieve a more consistent flight path across the ground and should improve flight path conformance over Noise Monitor 7. Steve, that was the last question we had come in.
All right, well, I'd like to thank both Rob and Jose for helping out tonight. This will conclude our webinar presentation for the evening. We thank you all for joining in and making the Southern California Metroplex project a success.